Hello, Matt Davis here with more homework quiz help. This one is coming from section 8.4. Suppose we will be computing a 95% confidence interval for a population mean and that a recent sample of size 31 produced a standard deviation of 35.552. What sample size will be required to have a margin of error of at most 4.5? Enter your answer as a whole number. So the first thing we're going to do is make a few changes so that we're giving help rather than answers. Instead of a margin of error of 4.5, we're going to do a margin of error at 4.0. And instead of doing a 99% confidence interval, we're going to go ahead and do this at a 90% confidence level. All right, so let's go ahead and start processing this. So first of all, what setting are we in? We're looking at a confidence interval for a population mean. And then what information did they give us? We have a recent sample of size 31, so that tells us that n is equal to 31. And from that sample, we got a standard deviation of 35.552, but that is a standard deviation from a sample, so that is S. And I think that's it for information they gave us. So now let's target what is it they're actually asking us to find. They want to know what is the sample size required to get a certain margin of error. So sample size is n. So this is a little tricky because we have two sample sizes. We have a sample size of 31 already given, so is that the answer? No, that was a recent sample that gave us the standard deviation we have. Now we want to use that information to get a new sample that has a lower margin of error than the previous sample did. So that's a little confusing to have the double n there, but you'll see how that comes in as we move along. But the key is in red here, what sample size will be required. So we're looking for a value of n as our answer. So let's go to the formula sheet for some help with that. So on the formula sheet, first of all, you want to think about, are we doing mean or proportion? And we're doing a confidence interval for a mean. So that puts us on this line right here. This one is all about confidence intervals for a mean. And then in terms of that, what are we looking for? We want a sample size, so we're looking for the formulas that say n equals. And then we have the choice of these two, so which one do we use? Well, the key decision point there is the type of standard deviation we have. They gave us a sample standard deviation S, so we're going to use this one right here rather than the other one, which involves either sigma or a guess at sigma. So we've nailed down what formula we're going to use. We're picking the one in green because it has S in it, and S is the kind of standard deviation we were given. So let's head back over and write that down and then continue from there. So our formula that we're going to use is n equals t star times S divided by the margin of error that they want, and then all of that is going to be squared. So starting to assemble the pieces, we have S already. The S was given to us as 35.552. The margin of error they want is 4.0. So the only piece missing from the formula is the t star, and that comes from our confidence level, which is 90%. So let's use that confidence interval to think about the value of t star. All right, so 90% confidence level. So we'll put 0.90, decimal form of that in the middle. That leaves 10% left over. Cut that in half, put 5% or 0.05 on each side. And then this will be t star right here. But we need to, when finding a t star, we need a df. Since this S right here came from a sample size of 31, we are going to use that to say the df for this curve is 31 minus 1, or 30. So because we're using an S from that old sample, we need to use that old sample size when thinking about the df. So we want t star to be t of 0.05, because that's the area in the right tail, with a df of 30. So let's go look for that on our formula sheet. So t of 0.05, so that's this column right here. So we want to be somewhere in there. And then we have a df of 30, so that means we're in this row right here. Zooming in on that a little bit, the spot where those two cross each other is right there at the 1.697. So We're in the T of 0.05 column. We're in the row with 30 degrees of freedom. Those cross each other at a T score of 1.697. So let's go back and write that down. So our T score is 1.697. That's our T of 0.05, which also means it's our T star. All right, so we've assembled all the numbers we need. Let's go back up to the formula and start plugging in. We have T star 1.697 times S, which was given to us and was 35.552, and divided by the margin of error they want, which was 4.0, and then square all of that. All right, so let's go to the calculator and see what we get for that. So open parentheses, because all three of those numbers need to be inside of those brackets. The formula shows a bracket, but on the calculator, bracket versus parentheses, it doesn't matter. So you don't need to worry about that. And then make sure you get all three of those numbers in before you close the parenthesis. That way when you add the square, you're squaring all three of those numbers. We do that, we get 227.4949. And we need to round that to a whole number. But let's go ahead and write it down in decimal form first. So we'll do 227.49. And then what is that closer to, 227 or 228? Well, it's actually closer to 227 because the digit after the 7 is a 4. However, when you're calculating sample size for the purpose of getting a desired margin of error on a confidence interval, the place where you can make a mistake is having a sample size too small. Rounding down risks having a sample size that's too small. So we always round up, even if that's not the closest. So our sample size that we would enter into active learning would be 228. All right, so where are some of the places this can go wrong? Sometimes people will look up their T star using the N of 31. Make sure you're remembering to convert that N to a DF, and then the DF that you're using comes from that old sample size of 31. That can be confusing, so make sure you're watching out there. And then the other tricky spot is having a number that looks like it should be rounded down, and yet we round it up. But that's just what we always do here to make sure that we don't end up with a sample size that's too small. The other place this could go wrong, I suppose, is using the wrong formula. So what we have to remember there is that because our standard deviation came from a sample, that means they gave us S, so we need to use the formula that has S in it. All right, hopefully somewhere in there you saw where this went wrong for you, so good luck to you as you head back to the quiz.